verify each identity. Okay, so here the first one, you have cosine square x times 1 minus cosine 2x is equal to sine square x times 1 plus cosine 2x. Sometimes for these identities you'll have multiple methods in different ways. Either you can start from the left hand side, simplify the left hand side, and then prove that it is equal to right hand side, or if the right hand side is bigger, you can simplify the right hand side and bring it show it as equal to the left hand side. And sometimes you can simplify both the left hand side and right hand side, and eventually you can get the same statement on both the left and the right hand sides. I think the third option works here in a better way. Let us see. Now I think I'll be using two identities. The first one is the Pythagorean identity. We know that sine square theta plus cosine square theta is equal to 1. That's one identity we'll use, and the other one is here 2x is there. So we know that cosine 2 theta is equal to cosine square theta, the double angle identity, cosine square theta minus sine square theta. Alright, okay. Now on the left hand side we have cosine square x times 1 minus this cosine 2 theta is same as cosine 2x. I can write this as what? Cosine square x minus sine square x. So 1 minus parenthesis cosine square x minus sine square x. Close the parenthesis for this and the other one for the first one is equal to sine square x times 1 plus, I don't need a parenthesis here because it is a plus, and cosine 2x formula is what? Cosine square x, I'm just using the top one, minus sine square x, that gives you cosine 2x. Alright, let us use the distributive property. And first let me do this piece. Alright, cosine square x times 1 minus, and remove the parenthesis means it is not, we can consider 1, so minus 1 time cosine square x is cosine square x, negative of negative is positive, sine square x. Okay, close this parenthesis, that is equal to here sine square x times, I'll write 1 minus sine square x together, 1 minus sine square x plus cosine square x. Okay, now what happens? Next step, I have cosine square x times, what is 1 minus cosine square x? From this identity, from the Pythagorean identity, sine square theta plus cosine square theta equal to 1. Alright, so if I remove this, if I move it to the other side, what happens? It will become 1 minus cosine square theta, right? This moved on to the right hand side, subtracting cosine square theta, we say, right? When you take off, this is gone, leaving behind only sine square theta. So sine square theta is equal to 1 minus cosine square theta, right? Sine square theta equal to 1 minus cosine square theta. So here, instead of 1 minus cosine square x, I can write sine square x. 1 minus cosine square x is sine square x. Plus, I already have a sine square x. One more is there, right? Over the left hand side. Now on the right hand side, it is sine square x times, tell me, what is this 1 minus sine square x? Making use of the same first identity here, Pythagorean identity, 1 minus sine square theta is equal to cosine square theta. So, I'll remove this. Instead of this 1 minus sine square x, I can write down cosine square x plus there is one more cosine square x. Already, you are good so far. Just making use of the identities. Now, in the next case, I have next step rather cosine square x times sine square x plus sine square x. That is 1 sine square x plus 1 sine square x. 1 plus 1 gives you 2 sine square x. Right? Same quantity, like the same quantity is repeated. So you wrote down twice sine square x. And over here, sine square x times cosine square x plus cosine square x. 1 cosine and 1 cosine gives you 2 cosine square x. See, you are almost there. Now write the numerical factor as the first one. So 2, I can write sine first if I want to, 2 sine square x. Cosine square x is there on the left hand side. On the right hand side also you have 2 times sine square x times cosine square x. That is proved. Okay, right, the left hand side is equal to the right hand side, hence it is proved. Right, nothing extraordinary, just make use of those two identities and simplify. Please practice that, you do it again by yourself so that you will be comfortable. Alright, now this next problem, you have cosine x over 1 plus cosine 2x is equal to 1 over 2 cosine x we have to show. So in this, we will simplify the left hand side and try to go to the right hand side. Okay, let us start off from the left hand side. I have cosine x and in the denominator 1 plus cosine 2x, and you know that cosine 2x, cosine 2 theta formula, just now you learned that it is cosine square theta minus sine square theta, or in this case I can write in terms of cosine as 2 cosine square theta minus 1. This is another way of writing cosine 2 theta, right? It is a double angle formula, you know. So cosine 2x can be written this way, just theta becomes x. So that is what, 2 cosine square x minus 1. Alright, now what next? In the denominator I am seeing a plus 1 and a minus 1. Plus minus 1 cancel off. So you are left with cosine x over 2 times cosine square x. Alright, now that is simple. What happens? On the numerator I have 1 cosine x, in the denominator cosine square x means it is cosine times cosine, right? So I can cancel off one of that. It is just like, suppose if I have a over 2a square, suppose if it is like a over 2a square, it is nothing but a over 2 times a times a. Alright, so a cancels out one time with this a cancelled out one again, right? So that gives you 1 over 1 divide 2a. Alright, all this story we don't do it, just we'll cancel off here, like this is a count, and here from a square 1a is gone, left with the 2a. That's what I did here. 1 over 2 cosine x. Okay, 1 over 2 cosine x, is it the right hand side? Yes, on the right hand side you have 1 over 2 cosine x, and that's what we ended up getting. Started from the left hand side, this left hand side you started and use the formula and simplified, and you have the right hand side. So the left hand side is equal to right hand side, hence it is proved. Okay, alright, thank you.